since they're not lined up properly, I have an x and a y and a y and an x. I'm going to take the first one because it's in xy, but it doesn't really matter. It could have been yx. It doesn't matter. But as long as both equations are lined up properly, you're going to be okay. Now, this is a positive 2y. I'm going to put that under here. That's a negative x. I'm going to put that under there. And my number is a negative 19. Now, so I have opposites here. What can I do? Multiply what? Multiply the entire second equation by 3. And I'll show you why in a second here. First equation, 3x plus 4y is equal to negative 23. Then we get negative 3x, because what's 3x plus negative 3x? 0. 3x plus 2y is 6y. Then times negative 19. Well, 3 times 20 would be 60, but you're 1 less 3 times. So it's going to be a negative 57. Now, add them up. That's 0. That's 10y. Negative 80. So y is equal to what? Negative 8. Now, instantly, when you figured out y is equal to negative 8, and it looks like it worked out pretty good for us, I could just go right here, and I know it's going to be b. Because it's the only one that has the negative 8 in it. You switched them? So you just did it right from here? I did that too. The first time I did this, I just said, oh, yeah, I got a negative multiplied by negative 4. And then I think you ended up probably somewhere here. That'll trip you up. Whenever you're doing a system by hand, make sure that they're lined up by x's and y's. And you'll be all set. All right, now, this guy. This has a slope of 1/7. So 1 over 7. What is this 1 going to change? The x or the y value?
The y.
All right, so it's a change in y. The 7 is going to change what? It's going to change x. So I would do this. I would just create an xy table. Where's the one point, the only point that's on the line? Well, it tells us we start at the origin. So there's 0, 0. So for the 1's, I got to add 1 to it. Or for the x's, I add 7. And for the y's, I add 1. So it'd be like 7, 1. Is there a 7, 1 here?
Yeah, no.
No, there's a 1, 7. It's there to trip you up. And so if you didn't understand it was y over x and you thought it was x over y, that's the one there to trip you up. The next one would be add 7 to here, you get 14, 2. And that would be D. But ladies and gentlemen, there's a different way that you could have done this. You know the slope. You know the slope is, well, I was going to say you could take, go with this. Come up with the tables and you'll be all set.
So wait, if I had to show work, that's the way I should do it. Because I didn't show work on it. I just like did it in my head.
Well, hopefully it'll work next time.
Oh, I got it right. That's fine.
Okay.
I am.
All right. Now, number 4 here. For the function g defined above, a is a constant and g of 4 is 8. So when you have g of 4, what's this value? Is that x or y?
X.
X. So x is equal to 4. So if I had g of x was equal to a squared plus 24, I want to do g of 4 is equal to a times 4 squared is equal plus 24, and that's equal to how much?
Wait, where does the, oh, 8.
And that's equal to 8.
That makes a lot of sense.
So 16, because 4 times 4 is 16, so 16a plus 24 has to be equal to 8. Subtract 24. So 16a is equal to negative 16. So divide by 16, divide by 16, a is equal to negative 1. So I know g of x is equal to negative x squared plus 24. So I want g of negative 4, which would be the opposite of negative 4 squared. What's negative 4 times negative 4? 16. So I want negative 16 plus 24, which is 8.
So both of them want the same answer.
Well, here's the thing. What's happening to my x value?
Oh, it's getting square root. So
It's being squared, right? So it's going to end up being 16. So when I know x is 4, I'm going to get a 16 there. When x is negative 4, what am I going to get here? A positive 16. So if x was 4, when x equals 4, x squared is equal to 16. When x equals negative 4, x squared is equal to 16. So is this number changing at all in the problem? So if I had a 4 or a negative 4, it's not changing the problem at all. So if I knew when I got with a 4, my answer was an 8, does it make sense that if I plugged in a negative 4 and it's not making any change at all because it's coming up with the same answer for x squared, that I should get the same value that we had here?
oh, like a reciprocal. Oh, not reciprocal, like a,
Yeah. I know what you're talking about.
absolute value. There it is.
So since 16 and 16 are both going in here for 4 and negative 4, I know the answer was 8 here. The answer here has to be 8 because the x squared value is not changing at all. So I don't care what a is. Whatever a was, it happened to be a negative 1. It didn't matter because we would get our answer. Now, I like the backside of this a lot. Now, here's the case. You see how there's an 8 to the x and a 2 to the y? Can I take 8 to the x power? And can I change this into 2 to some power?
Yes.
What's 2 times 2? All right, so that's 2 squared. So what's 2 times 2 times 2? 8, which is 2 cubed. So 8 is really 2 cubed raised to the x power. So that's 2 to the 3x, isn't it? Now, the whole idea in this problem is that you want to, since 2 and 8, 8 is a power of 2. It's just 2 to the third power. We end up with 2 to the 3x over 2 to the y. All I did is I took this guy and I said, this is really 2 times 2 times 2, all raised to the x power. So, and then I said, all right, that really means 2 cubed raised to the x power, which is 2 to the 3x power. 2y, because that's what the expression actually is. So I rewrote this with the same things here because I want to use the property. I want to use the property a to the m power divided by a to the n power. When I have the same bases, because this question is all about, do you know your properties for exponents? So if I'm dividing exponents, am I going to add or subtract the powers? Subtract. So this is a to the m minus n power. So this guy is 2 to the 3x minus y power. Do I know what 3x minus y is? What's 3x minus y equal to? 12. This is really equal to 2 to the 12th power.
How do you get 2 to the third power 3x minus 1? How do you get that part?
This rule right here. When you're dividing powers with the same base, you can subtract the powers. So here, I had 3x and a y, I had 3x minus y. But I was given 3x minus y is equal to 12. So I could take the 3x minus y and put a 12 there,
That's a tricky.
but now you've seen it. So if you have something like that, they want you to change it to make that into a 2.
That makes so much sense.
That they want you to change that to make that happen.
I was trying to do like, 3x equals 12 minus y, and all that.
Oh, and change all the stuff around. It's that's kind of tough. You would get an answer that wouldn't appear here. All right, now you guys are gonna kind of be upset about this one.
What?
Now, if you had a triangle, and I'll just let you in on a secret. Say that's A, that's B, and that's C. And that was 3, that was 4, and that was 5. Now, x is right here. So the sine of x is equal to the opposite side, which is 4, divided by 5. Cosine of x is equal to the adjacent side, which is right here, which is equal to 3 over 5. Now, if I'm looking at y over here, the sine of y is the opposite side, so it would be 3 over 5. Now take a look at these two. Are those the same?
Yeah.
So the cosine of x is equal to the sine of y. What's the cosine of y? It's the adjacent side, which is 4 divided by 5. And now, in here, if that's x plus y has to be equal to 90 degrees, because you're in a right triangle. So, if I wanted to figure out what that y was, subtract an x, y is equal to 90 minus x. So, if I know the sine of x is equal to 4/5, and I know the cosine of y is equal to 4/5, I know the cosine, I'm going to change y into 90 minus x is equal to 4/5. Because I know when one side's a 4, when one of the legs is a 4 and that's a 5, it ends up being a 3, 4, 5 triangle. It's just, there are special triangles out there. One of them is a 3, 4, 5 triangle. And since I knew one of the legs was 4 and the hypotenuse was 5, that had to have been a 3. You could have checked it out with the Pythagorean theorem if you wanted to. Now, 4/5, you could do this, 4 divided by 5. 4 divided by 5. Or you could have actually done this, 5 divided by 4. Or if you would have put 0.8, that would have been fine too. So those three answers should get you the right answer every single time. Alright, so now the last problem from this set. If a equals 5 times the square root of 2, and 2a equals the square root of 2x, what's the value of x? Well, do I know what a is?
Yeah. 5 to the square root of 2.
Alright, so wherever I see an a, I can put in 5 times the square root of 2, can't I?
Yep.
So I can put that in right here. So I can change it to 2 times 5 times the square root of 2 is equal to the square root of 2x. Now, when I multiply by 5 times the square root of 2, okay, I can go 2 times 5. What's 2 times 5? 10. Can I go 2 times... Do I do that, or is it just 10 radical 2? It's just 10 radical 2, and that's equal to the square root of 2x. Now, what do I want to do to get rid of the square roots? Square both sides, absolutely. So I want to square that, and I want to square that, which means this is going to be 10 squared, and that's going to be the square root of 2 squared, and that's equal to the square root of 2x quantity squared. What's 10 squared? 100. What's the square root of 2 squared? 2. If you take a square, and it comes from this. If you have the square root of a squared, it's equal to a. So because it's like adding and subtracting. If you add 3 and subtract 3, you get back to the same number. This is if you take its square root and then you square it, you get back to the same number. Now what's the square root of 2x quantity squared? What happens with the squared and the squared root? They go away and I'm left with 2x. So now I'm not even going to bother multiplying there. I'm just going to divide by 2. These 2's divide out, so x is equal to what? 100. So you could put in, if you wanted to, you could do this.
Wouldn't it be 50?
Well, when I divide by 2 here, these 2's divide out, and I'm left with 100. So you could type in you could put in the 100 here, and go 100, or you could put 100 like that. So there's no rule that says that you have to start from the left and move to the right, or you could start from the right and move to the left. Either way, they say that if you put in the answer and it's right, as long as you justify it to either the left or the right, and justifying just means make it line up to the left or line up to the right, it'll work. But going over these, do these kind of illuminate what was going on with these problems? Alright, I know this guy's a little bit tricky because you had to transform the 8x, or yeah, 8x into 2 times something, or 2 to the some power. But you guys can do it. The biggest thing is you need to see some of these before, like with this guy, you might not have a clue what's going on with that. But now, remember your exponent basis, the rules for x, you got to use them with the same basis. This cosine one, the sine and the cosine one is kind of a trick question. Because, well, it's not really a trick question, but it's saying the sine of A is the cosine of B. Because, and the whole idea with this is the opposite side of A becomes the adjacent side of B. So, since the sine has the opposite side in it, and the cosine has the adjacent side in it, it switches on you. So the sine becomes the cosine becomes the sine. Or the sine becomes the cosine becomes the sine. The tangents become, one tangent is the other one flipped upside down. So one tangent is the reciprocal of the other one. Because it goes opposite over adjacent, well then it becomes now the other one becomes opposite over adjacent, but the opposite was the other guy's adjacent. So it flips. So if this guy was 3/4, this guy would be 4/3. So hopefully that helped.